So in this video we're going to take a look at question 1 from 2017 higher level maths paper 2. Let's get right into it. So question 1 says that when Connor rings Kira's house, the probability that Kira answers the phone is 1/5. So Connor rings her house once every day for 7 consecutive days. We have to find the probability that she will answer the phone on 2nd, 4th and 6th day. So we have 7 days. And on day 2, 4 and 6 she answers the phone, and the probability of that is 1/5. So 1/5 by 1/5 and 1/5. And the other 2 days she doesn't answer, and probability of her not answering is the complementary probability, which is equal to 1 minus 1/5 equal to 4/5. So here we have 4/5, 4/5, 4/5, 4/5, and probability of those events. To get the total probability, you just need to multiply those values, and if you multiply that, you'll get the fraction of 256 over 78,125. And then we have to find the probability that she will answer the phone for the 4th time on the 7th day. So this is how I'm going to represent this. This is the first 6 days. 1, 2, 3, 4, 5, 6, and then here we have the 7th day. Now we have to recognize that for the first 6 days she could answer any of those 3 days. So we're selecting 3 out of 6. We have combination of 3 out of 6. So we're going to use the Newton symbol. A probability. So we're selecting 3 out of 6, and those 3 probability of success are 1/5, and we can say that this is cubed, and the probability of the failure is 4/5, also cubed, and then we're multiplying it by the final probability, which is going to be 1/5. So multiply by 1/5. So if we put that into the calculator, we get that probability equal to 256 divided by 15,016.25. Then we have, we're told that Connor rings her house once every day for n days. We have to write in terms of n the probability that Kira will answer phone at least once. So the probability that she doesn't answer a phone any of those n days is the probability of her not answering to the power of n, because every day she doesn't answer, we just multiply one more time by 4/5 to the power of, so then probability that she answers is 1 minus 4/5 to the power of n. So that will be the answer to this question in terms of n. And then we have to find the minimum value of n, for which the probability that Kira will answer the phone is at least once is greater than 99%. So we're told that 1 minus 4/5 to the power of n has to be greater than, so this is probability that she answers, has to be greater than 0.99. So then moving 1 to the left hand side, minus 4/5 to the power of n is less than minus 0.01 is greater than. So then dividing both sides by minus 1, we're going to get that 4/5, all that to the power of n is less than 0.01. So if I take logs of both sides, I'm going to get n log of 4/5 has to be less than log of 0.01. So note that if I'm solving this for n, so I'm going to divide both sides by log of 4/5, which is a negative quantity. So if this is a negative quantity, then I need to change the sign of my inequality. So I'm going to get that n has to be greater than log of 0.01 by log of 4/5, and the quantity that n has to be greater than is equal to 20.6377. So the minimum value of n in that case has to be 21. So, thank you for watching, and this is Mr. Ozek out.